Alrighty. Okay, here we go. All right. So stacks and queues. They have a very similar idea to it, yet kind of different. So let's take a look at what they are, and then we can take a look at a few code version of these. So to start with, what is a stack? Now, in a very bookish definition, a stack is essentially a linear data structure in which elements can be inserted and deleted only from one side of the list, called the top. A stack follows the LIFO, last in, first out principle. The element inserted at last is the first element to come out, and the insertion of an element into the stack is called push. And the deletion of an element from the stack is called pop. So pretty basic. Last in, first out. Whatever element you enter at the very end will leave the stack at the very beginning once you do a pop operation. A stack kind of looks like this, where it just goes up and stacks over one another. And the item at the very top is called the top. And usually that's the one that gets removed from your stack. So moving forward, what's a queue? Now, a queue is a linear data structure in which elements can be inserted only from one side of the list, called the rear, and the elements can be only deleted from the other side, called the front. So over here, it's actually working in the very opposite way, because over here, the first item being entered will be the first item being removed from your queue. And in a stack, the operation of entering an element and deleting an element, we call that pop and push. For queue, we call this enqueue and dequeue. A queue essentially looks like this. As you can see, items are getting entered in the rear, and from the front, it's getting removed when you dequeue it. So these are the very basics of what they are. Let's try to take a look at a more code version for these. So let me go into VS Code. Yes, Samina, you have a question? I'm not sure if you're speaking because I can't hear you. Maybe you can check your audio, or you could even write down in the chat.
Can you hear me now?
Yes, I can hear you now.
Okay. So I was saying that this week we've been studying about hash tables and linked lists and stacks and queues. So these are all like different kind of data structures, right?
Yes.
And these are usually covered in CS courses. So what I'm asking is that in the interview questions, you're saying that the interviewers they ask all these questions about the different data structures.
They might, yes. So there's a website where you could practice interview style questions. It's called LeetCode.
Uh-huh.
Over there, you'll get a lot of these different kinds of interview style questions. Um, most interviews, most technical interviews, they actually try to check your core fundamental concept of programming, because the whole idea of programming is that, you see, it actually changes very quick. So if you have the fundamentals correct, then you can switch from any language to another.
Yeah.
So they
And
check for these. Mhm.
the concepts that that you were going over, for me, I did it like over 25 years ago, and the this hasn't changed. The fundamentals haven't changed. It's
Exactly. The languages change
changing.
because
Yeah.
I learned all these in C,
Hmm.
C, C++, and Java, mix of all these, to be honest.
Right.
But right now, if you see, there are a lot more languages covering these concepts. Like now I'm doing it in JavaScript.
Right.
So
Right.
the languages change, but the core fundamental concepts, they don't really change. Like constructors, classes, for any object-oriented programming language, these will remain the same.
Yeah. That's interesting. So yeah, but what I was kind of saying was that so the interviewers, they usually ask all these data structures. I mean, they go back to those CS fundamentals, and so there are people who are coming from different areas that they're not CS graduates, or but so it's good for them also to understand these concepts, basically, of what I
Exactly.
understand, like you guys are trying to make us understand and be aware of, is that we should also, I mean, others who are coming from different backgrounds should also know these elements of CS.
Exactly. Because you see, these aren't the kind of concepts you actually go through every single day.
Yeah.
So even for like an experienced programmer who has been coding for a while, they also need to kind of revise all these before technical interviews, because lead code actually can get a little tricky at times.
Mm,
So the only way to get better at it is practice. That's the only suggestion I have. Practice is the only solution for lead code or
mm,
interview style questions, because you don't know what will come up, right? It's all about the fundamentals and how you want to go about it, the problem solving process,
mm,
things like that.
yeah.
That's the best part about this field, is that even though the technologies change very quickly,
Mm,
the fundamentals remain the same. So even if the technologies change, you're not out of the field. You can easily relearn something and get back into it.
right, right. Yeah, I'm pleasantly surprised, actually, because yeah, it's familiar to me. All these things are, alhamdulillah, it's familiar.
Yeah, these are very helpful when it comes to programming or technical interviews for
Mm,
any job. These are things that they might ask, because it is actually very important to have a good idea of what data structures are and how to go about them.
yeah, but Tasneem, like for the past 6 months, we've been coding, right? We never needed. I know we need stacks and queues. I understand. But linked list, I know you can use that. It makes it more efficient. Like you don't have to allocate so much data, as in, if when you're defining an array, you kind of allocate data in the memory. But with linked list, it's like more flexible. But generally speaking, I'm thinking, um, I mean, these are concepts, but students have not used these concepts. So for them, how would I mean it would still be challenging for them to understand why would they need a linked list? Why would they need I mean, hash tables, I understand, but and well, I think more if when you guys are explaining it, if you can explain it more towards how and when in a situation you're going to use these data structures, I think that would make more sense to. Otherwise, they're all the time they'll think just to have objects or have arrays. defined, because that's what we've done up till now uh, while we coded these past 6 months. So
Right.
just my little feedback.
Yeah, for sure. The thing about these data structures is that you won't see people using it a lot in day-to-day basis, but the things like this is what makes a programmer with proper computing concepts different from a programmer who just learned how to make a website or an application. Because these are the kind of concepts that essentially make or fine-tune your application. For example, just arrays actually might be useful, but think about the runtime and everything. That's when you're actually creating a high performance website or a high performance application in general. These kind of things are very important, like how much time it's taking and whether it's doing everything smooth or not, the memory allocation. Because when you're building an application, say a phone application, if the application is around 500 megabytes for like simple functionalities, you probably wouldn't want to waste your space on that. You'd
Yeah,
probably go for something that takes up less space. So these are the things that make those kind of changes. Now, luckily, in the current age, a lot of these functionalities have been taken over by the libraries that we use. So they take care of it for us. But in some case, when you actually need to do everything from scratch, or you need to, because these data structure or algorithms, these algorithms actually can be used in normal projects as well. You can even create a whole project system with the idea of linked lists. Like that can even work with databases too.
yeah. Yeah, the concept of, how to manage the pointers, and because the linked list is going to dynamically grow based on your need. You don't have to,
Exactly.
physically allocate beforehand so much amount of data, memory, to that program.
Exactly. The whole point is to get rid of boilerplate coding, which is just writing the same thing again and again.
Mm,
So if you're copying or if you're writing 5 lines of code in like 50 different places, that's a lot of work if you think about it. The
mm,
whole idea is to make everything kind of automated so that it's ready to be used just by writing down a single line of code. And that's why React is so good.
yeah.
Having your own component set up, you can use it as many times as you want. You could reuse a component several times. It won't make a difference. That's what makes it different from just doing HTML, CSS, JavaScript websites. Okay, let's get
Okay.
back to it actually. Let's start with our stacks and queues. I will share my screen. But yes, thanks for the feedback, Samina. We will definitely keep that in mind. All right, so let me create a folder. So today is March 21. All right. But where did I open this? Okay, it's fine. Okay. So let's first start off with stack, okay? So what I'm gonna do, I'm gonna create a min stack application. What's a min stack application? It's essentially a stack, but I will be keeping track of the minimum element in the stack as well. All right, so let's begin. Okay, so to start with, I'm gonna do the same as I did for linked list. The first thing that we need to do is create our class. So I will call this class min stack. stack class created. Let me create a constructor. Okay. So now for the constructor, let's think of what we would probably need. So we would definitely need the stack itself, right? And another thing that we would probably need is a stack for all the minimum elements. So let me create that is equal to, all right. Okay, so the constructor is created. Now, we would need the following functionalities. If I comment out, push functionality, then pop functionality. What else could we need? We might want to see the top element. See top element. And we also might want to get the minimum value of the stack. So that's something that we might want to see as well. So get minimum value. Okay, so this seems good. Anything else? We might want to display the stack as well. So display, okay, no. Display stack. Okay, so we have it all set up. Now let's just slowly begin. So to start off, let's create the push functionality. So why don't I call this push element? And for this, I would require I wonder, is this commented out as well? Doesn't look that good. I guess it is what it is. All right. Okay. So for this, we would require a parameter which essentially will get the value of the element being pushed into the stack. All right. So to start with, we would probably just push this into our stack. Okay, then dot push. So this dot push is actually a built-in JavaScript function that essentially inserts value into arrays. All right, so this dot stack dot push should work. Now, the next thing I would probably want to do is check if this is the minimum value or not. If this is the minimum value, then I want to push it into the min stack as well. So let's do that. So this dot min stack dot length is equal to 0, or x is less than equal to this dot min stack, and inside this I will just put in the index of this dot min stack dot length minus 1. So what this will do is it will check if the element being entered is that less than equal to the top value of the min stack. So length minus 1. So if my stack length is 8, 8 minus 1 is 7, which means it will check the 7th index, which is the last one, or the top one. So it goes like 0, can annotate or write down here. So it goes like 0, 1, 2, 3, 4, 5, 6, 7. And I will be checking out this one right here. The 7th index. Okay. Let me clear my drawings. All right, so moving forward, so once I've put in the condition, what I can do is just push it to the min stack because it meets the criterias, and that should be good for pushing an element. All right, so what if we wanna pop an element, which means I want to get rid of an element. So let's call this pop element. And for this, I don't really need any parameter because I'm not entering anything, just removing things. So for this, the first thing that I would probably check is if this stack dot length is equals to 0, which means if the stack is empty or not, is equal to 0. Now, in a case where this is 0, what I can do is straight just return null, right? Otherwise, what I can do is write down const popped is equal to this stack, this dot stack dot pop, and here we have it. So once we get rid of the value from the stack, we are storing it in a variable. Why? Because we are gonna check if that particular element is in the min stack or not, and if that element is equal to the, or in other words, if that one is the minimum element in the min stack. Okay, so let's check that. If popped is equal to this dot min stack, then the index would be this dot min stack dot length minus 1. Okay. And as for my functionality, this would do this dot min stack dot pop as well. Right. Okay. And lastly, if that's not the case, then I would just return popped. Popped. P-O-P-P-E-D. Actually, I think I might have to do it regardless. So else doesn't really make sense. Let's just do this. Return popped. Okay. So we have the push and pop function ready. Let's try to do a display function to make sure that we can at least see what the stacks hold. So this function would look like display stack, and inside console.log main stack, comma this dot stack, and again same thing. This will become min stack, and this will become min stack. Perfect. All right, let's try to do a test run on this, see what happens. So node, actually, I'm missing something. I have to create an instance for the stacks, right? So let's just create a value. Actually, I think if I make this, okay, this is good. I wonder. All right, so that's the, okay. So I could just name this min stack. I'm just gonna call this that. And equal to new min stack. Perfect. Next, let's try to do a push min stack dot push element. Let's try to push in 8. Let's try to do this for a number of times. Say 4, say 3. Okay, let's try to do a display with this first. Node min stack. All right, I didn't call the display function. My bad. Min stack dot display stack. Node min stack. Okay. So right now, all of these are in the min stack. It's probably because of the order. What if I enter another over here that's higher, say 7? What happens then? Node min stack. Okay, so 7 doesn't actually go into the min stack because the top is not actually bigger than the amount or the number being entered. So in that case, 7 will just remain in the regular stack. Now, what if I want to do a pop? Min stack dot pop. In this case, I don't have to enter anything. I can just do that. I don't want to change the balance of it, so I'll just enter another. Call this what, 10. Okay, so let's do this twice actually. Before I do the pop and after I do the pop. Perfect. So node min stack. Okay, something's wrong. Popped is not defined. Right, okay. This makes sense now. That's because this was declared in the else block. Command C, get rid of this. Right. So for now, let's keep this as null. All right, node popped. No, that's the wrong name. Min stack. I wonder. Okay, there you have it. All right, so everything seems to be working fine. We're entering these numbers, 7 and 10 not in the min stack because they don't fulfill the requirements we set in as our condition. And then we do a pop and 10 is removed. Hence we have all the elements till 7 and in the min stack up to 3. Right. Okay. So what if I want to see the top element right now? Let's try to make a function for this. So top will actually look something like if. Now for this, first we're checking if the stack is empty or not. So we do this dot stack dot length is equal to 0. If that's the case, then just return null. Otherwise, what we can do is return this dot stack and the last element of the whole stack. In that case, it would be the top length minus 1. All right. We'll see that if it works in a bit. Let's also make this function where we get the minimum value as well. In that case, actually, both these functions are very similar. We're essentially just taking a look at the top value for both these stacks. So let me call this get min, and I'll just paste this and make some changes right here. So it's gonna be min stack, and this will be min stack again. I'll have to change this one too. This makes sense. Hopefully this will work. So let's try it. Let's do a console log and oh no, that's confirm. Console.log, and inside this I'm gonna do minstack.top. All right, and I'm gonna do this again for get minimum, or in other words, get min. So let's do it. Node, and what do we have here? Min stack. Okay. All right. So the minimum, the top value of the main stack is 7, and the minimum value in the entire stack is 3. Any questions so far? Perfect. Yeah, these are pretty simple concepts, yet very important in the long run. All right, so since we have that out of the way, let's try to make a min queue as well. It's not actually a min queue, it's more like, let's just try creating a queue just for reference. Okay, I will call this queue.js. So the idea is similar. They're both essentially working like arrays, but the difference is in the stack, if you see, we are getting rid of the last entered item first. So it's a last in, first out system. But for the queue, it's going to be different. It would be first in, first out. So whatever item is being entered first will be leaving the queue first. So let's start off the same way by declaring a class. I'm just going to call this queue. Okay, so I'm going to need a constructor. And here I don't need anything for now. Can just write this dot queue is equal to this. Okay, constructor is ready. Okay, so the first thing that we would need is enqueuing something element dequeue element what else maybe we want to see the peak, which would essentially be the first item, and we might want to see the size as well, I guess. Size, and lastly we want to print it. Very simple. Let's take a look at it and how we will be doing it. So to start with, I am gonna write down enqueue, and for this I will be writing down a parameter because this needs the number being entered into the queue. So one thing about real life concepts, this queue concept can actually be very useful when you're making a system where you have some sort of like a wait list. This could be a very good concept to use in projects like those. Okay, so let's get back to the code. Enqueuing it means this dot queue will get the value pushed into it. Simple as that. For dequeue, we don't really need any element right now. We can keep it empty for the parameters. Exactly. Doctor's office, patients being queued, even for phone calls, to be honest, because I understand in like a system where you're handling phone calls from different customers, you would put in separate IDs for each and every one of them, right? And there has to be a system in which the phone calls are answered. In most cases, it's first in, first out, which is kind of the concept of a queue. So pretty much like that. And even if you're creating, say, a system managing inventory for like a warehouse or something, this idea of a stack could also be good, like stack or queue, whichever your policy is for your warehouse, depending on the kind of goods. Because some go by the policy of first in, first out. Some go by the policy of last in, last, first out. So it doesn't really matter which you're doing, but there are concepts for these to get implemented. So for DQ, what we're gonna do is we're gonna check if the queue is empty or not. So this dot queue, right, FIFO. Food items need to be LIFO. I think so.
Not LIFO, sorry, FIFO. First in, first out food items. Because they
Right,
expire, right?
exactly. All perishable items would ideally need to get sent out first, like fruits and things like that. But if it's canned products, or actually canned products are also perishable. I think there are different constants for canned products, like expiry date and things like that. But for goods that don't really have an expiration date, like products, maybe sunglasses or things like that, those don't have an expiry date. Those you can push out the inventory however you like. In most cases, they don't care, so it just becomes last in, first out. But yeah, for perishable goods, it has to be first in, first out. So this dot q dot length would be 0 if this was our empty queue. In that case, what we would do is maybe just do a console.log saying queue is empty. Console.log queue, okay, queue is empty. Okay, so that's good. Yeah, if that's not the case, we could just return this dot queue, no space in between, dot shift. So dot shift is a function that gets rid of the first item from your array. It's a built-in function. All right, so dot shift, that's good. Our DQ is ready as well. Let's try to create the print function. Okay. And this, let's just console.log this dot q. Perfect. Let's try it now. Node q u e u e. Okay, once should be good enough. Did the same mistake again. See, this is what happens when you come back to working with classes and constructors from doing web dev, because everything is already, running when you're creating a website. You don't have to call instances again and again. Okay, so let's write down an instance over here. Say const, and this is called q. So I will just write down q. New q. Is it capital? Yeah, it's capital. QUE. All right, it's all good. Okay, so q dot enqueue. Let's write down, say, 7. Let's enter a few more. So let's do this 8, 4, 10. And let's do a print over here, q dot print. And let's do a DQ. And then print again, q dot print. Okay, this should work. Node Q. Okay, here we go. So I'm printing this twice. As you can see, the first time it has 4 elements, 7, 8, 4, 10. But after dequeuing, the first element is gone, and now it's just 8, 4, and 10. So essentially our queue is functional. But now what if we want to see the peak element of this queue? Let's do that. Let's create a function peak and Command Z. Inside this, again, we're going to check if this is our first element or if the queue is empty in general. This dot queue dot length is equal to 0. And then we return null in that case. Now, other than that, what we can do is just return this dot queue with the index 0, because then it would be the first element and meaning that's our peak. For size, size. Actually, I should have made this function first. It would reduce a lot of typing for me. Return this dot queue dot length. Right, I should have made this first. Would get rid of a lot of typing from different places. Okay, so let's try it. Let's write down queue dot peak, and actually this needs to be wrapped around a console log. Console.log. Nope. Queue.peak. All right. Copy this, paste this. Let's check the size function as well. Okay, now let's run node QUE. Okay, so the peak is 8 and the size is 3. So everything is working just fine. Any questions, anyone? Anyone with any questions? All right, perfect. I mean, that's about it for stack and queue. Just some small examples to go through the concept. These are similar questions you'll get on the website LeetCode. Some might be a little more complex than this. Some might be easier. So it all comes down to practice for those questions. So definitely check that out because that will help a lot during technical interviews. And that's the whole point of going through these to make you guys industry ready. But yeah, other than that, for now, this is all I have for the stack and queue lecture. I guess if no one has any questions, we can go on a 10-minute break and we will come back for our office hours or lab. You guys can just raise your hand and we can go to a breakout room and help you out. All right, I guess I'll see you guys in 10 minutes.